Continuing lesson 4.4, if you look at page 209, example 3, they want us to simplify this expression. So similar to what we've been doing for simplifying, first of all, they're subtracting. You can add the opposite, and then we are going to distribute. Multiplying into all those different parts. So 1/3 times 2. 2, it's like 2 over 1, so that'd be negative 2/3. And then negative 1/3 x times, negative 1/3 times negative 3x. That we could put over 1. So if you multiply that part, negative times negative is going to be a positive, and we'd get 3x over 3. 3x divided by 3 would be x, or 1x if you like. And then negative 1/3 times 3, that's like 3 over 1, so that'd be negative 3 over 3. Negative 3 divided by 3 is negative 1. So you could put that as either minus 1 or plus negative 1. And then they combine those together. Technically they're both negative if you just put negative 1 2/3 plus x, or x plus negative 1 2/3, x minus 1 2/3. If you didn't notice those being the same and just getting it as 1 2/3, otherwise to combine negative 2/3 and negative 1 you have to get a common denominator, which would be 3. So negative 2/3 and then the negative 1 would be negative 3/3. Negative 2/3 and negative 3/3 is the negative 5/3 that the book's getting. Okay? So on the try it, we're going to make this into a more interesting problem here. And instead of minus 20n, I'm going to make it minus 20m. So for this, if you want to add the opposite first, you can. And then if you'd like to, you can go ahead and distribute. This is what we normally do. If you don't, the other option you have actually is that we have, by me changing this problem, we have like terms inside the parentheses. If you have like terms that are both inside the parentheses, you're actually allowed to combine those first. So just to show you an option of that, if we combine, so we've got 15m plus negative 20m would be negative 5m. So plus negative 5m, or just minus m if you want. And then we can distribute. So we're negative 2/5 times 10 plus negative 2/5 times negative 5m. Anytime with fractions, when you're multiplying, those whole numbers or integers you can put over 1. So we've got negative 20 over 5. Over here we got a negative times negative, which is going to be positive. Good. 10m over 5. And then always the last thing is we're going to see if we can reduce that or not. So negative 20 divided by 5 would be negative 4. And then 10m divided by 5 would be 2m. So we've got negative 4 plus 2m, or if you want to rearrange that, you could say 2m plus negative 4, or 2m minus 4 would also be the same. Those are not like terms at that point, so we cannot combine those, so that would be our final answer. So on the next page, key concept just kind of recaps things. Again, if they ask us to expand an expression, we're going to use the distributive property. We're going to multiply into everything inside the parentheses. Let's go ahead and look at the do you know how number 4. So shoes and hats are on sale, and we have an expression here that can be used to determine the discount when you buy shoes with the retail price of S dollars and hats with the total retail price of $24.80. Write another expression that can be used to determine the discount. So basically we're just finding an equivalent expression is what we're doing. You can see these are 1/4 off. That's how they got the 1/4. And this, again, this is actually just determining our discount, not what we're paying, but what we're saving off of the regular price. So don't get confused on that part. So to do that, we can distribute. So we'll do 1/4 times S plus 1/4 times 2480. The 1/4 S, 1/4 times S would just be 1/4 S. And then the second part, the 1/4 times the 2480, if you want to, you could just think about if you take 1/4 of something is the same as dividing by 4. So we could actually just divide by 4. If not, just put the 2480 over 1 and you'll multiply across and you'll get 2480 over 4, which means to take 2480 divided by 4. So you'll get there eventually if you don't see that right away. So when you divide this out, 4 goes into 24. 6 times, okay? And 4 goes into 8. And 4 goes into 0. 0 times. Okay. So that'd be 620. So we got 1/4 S plus $6.20. That would be our discount on that problem. Look at number 5. They want us to expand this. Again, expand, which means we're going to distribute. And just remember again, distribute. When you distribute something, when you're multiplying something, they don't have to be like terms to multiply. They just have to be like terms in order to add or subtract. So when you distribute that, we can just do a little rearranging. X times 4 is the same as 4x. And then you can say plus negative 3.4 xy if we do alphabetical order. That's the same as just 4x minus 3 4/10 xy. If you put yx instead of xy, that's fine. One thing to mention while we're talking about it, if you ever had two terms and one had xy and one had yx, and those were the only variables, those are actually like terms because it's just a matter of rearranging those variables to get them to be the same. So look at number 6. They want us to expand this. So again, as we've been doing, if you want to add the opposite first, you can. On this problem, we actually have like terms inside of our parentheses, so we can go ahead and combine those together first if we want. The negative 2/10 in front, if you want to reduce that to negative 1/5, you can as well. Once we get to this point, we can go ahead and distribute. Again, if you reduce the negative 2/10 to a negative 1/5, that's going to make things a little simpler for you, but I'll just act like we didn't see that. Just because. So the 3 we can put as 3 over 1, so this would be negative 6/10 plus negative 4x over 10. Negative 6/10 you can reduce to negative 3/5. And then anytime if you have a variable in the numerator, you can just slide it over to the side of your fraction if you want. So negative 4/10 reduces to negative 2/5 x. And this one, you know, if anybody switched this over to decimals, this would be negative 6/10 plus negative 4/10 x. Okay, and again, if you switch the order around with your x first, negative 4/10 x plus negative 6/10, or negative 4/10 x minus 6/10. And on that answer, with your variable, if you have the variable left in the numerator, like you have negative 2x over 5, that's fine. Normally they'll go ahead and slide it over to the side. And understand, if we had another x term and we had one in the numerator and one was just like 5x, those would be like terms. So even though you don't have to slide it over to the side, you would need to still recognize those as being like terms. Look at workbook page 52, number 10. Carpenter plans to extend the length of a rectangular desk by 7 feet. Let x represent the desk's original length. Expression 9 times the quantity x plus 7 represents the area of the desk surface. Where 9 is the width in feet, x plus 7 represents the extended length in feet of the desk. Carpenter thinks the area of the extended portion is 16 square feet. Which choice below includes the expanded form of the area expression for the desk surface and the correct area of the extended portion and the desk surface? So if we think about a picture here of what's happening, we kind of started off here with like a 9 by 7 rectangle, and then we're adding on a piece here. And that's kind of how they're coming up with this, because overall, if you look across the top here, this is 7 plus x, or x plus 7. Area is length times width, so you could think about 9 times quantity x plus 7. And then if we distribute that, we'd have 9 times x plus 9 times 7. So that'd be 9x plus 63. And so looking at our answer choices, the and I actually looked at this wrong originally. X is the original length, and then it's being extended by 7 feet. So actually, on our picture, the original part is actually our red rectangle, and then the extension is the black rectangle. So the extension is actually what we know, which would be the 63. So that would match up with answer choice D. And probably what they did, they got 16, they probably added 9 and 7 instead of multiplying those. We'll look at workbook page 52, number 13. An architect plans to build an extension for a rectangular bedroom. Bedroom is 5 meters wide. The original length of the bedroom is 8 meters. Length of the bedroom's extension is represented by x. So they're giving us an expression 5 times the quantity x plus 8 that represents the area in square meters of the bedroom. They could have just told us this information and then asked us to figure out an area. In that case, we would have had to think about the original part here being 5 by 8, and then the x part getting added on over here. Okay, we could have come up with this ourselves. We know area is length times width, so one way you could think about it, basically what the book's doing, one direction we've got the 5, the other direction together we've got either x plus 8 or 8 plus x. Normally we'll put the variable first, call it x plus 8. Or your other option would be to find the area of the original room and then the area of the extension and then add those together. That would be fine also. So on part A, we're trying to find an equivalent expression. Equivalent expression we would get by distributing. So we'll do 5 times x and the sometimes forgotten 5 times 8. Make sure you distribute to all parts there so nobody gets left out. So we've got 5x plus 40. Again, if you did it as separate, you could say the original had an area of 40. The new part had an area of 5x, and so altogether, adding those together. So 5x plus 40, that would be answer choice B. And then part B, what does each term of the expanded expression represent? I already mentioned that a little bit. So we could say something like 5x represents the area of the new portion and 40 represents the area of the original room. So this gives you an idea of how to expand expressions using the distributive property.